Hello class, we'll check question number 40 of your module. Try to solve very important question. See to it that the question comes to you clean. Just a moment. So there is a square frame given to us. This square frame is made to rotate in two choices of rotation. The first choice that we make is into the plane of the paper or screen, if we may say. We assume mass of this structure as m, the lattice, and these supports are light. There is no mass to be associated with the support. Square frame, in one case, is made to, as told, vibrate or oscillate in a frame perpendicular to screen, distinguishing it with a different color so that you can understand the way that it is rotating or made to rotate. It goes this way, I hope I'm legible. And then it takes this structure, a position as shown. This is into the previous position or up the plane, whichever way you take. Going back to the previous, then comes, moment please. Then comes the other one. The other one means the other mode of vibration in which this square is made to oscillate, keeping its position in the plane of screen. So it is made to move this way. Yet again, with the help of a different color, I'll show you position after some time. That bit up, logical, right? Yes, it'll be divorce of sense. How can it be at the same position? It sound rational. So from the sound of what I said, I'm changing it, showing the previous first, and then after some. Always, this is having something to do with, or I would say, much to do with a question in IIT Ritul where it is given to you There's a pitcher which is initially filled with water made to oscillate, and then that pitcher is kept in a cold ambience, wherein of cold milieu as we call, wherein this water freezes. So what will happen to time period is what they're being asked. In this question, what being asked is which will get displaced by maximum angle. So we are to work on same principle, drawing a parallel with this one. If I am to assume it being completely filled with water, then after some time, this rotation is read from center of mass frame S. After some time, when you come over here, then you can see for yourself that with respect to this frame S, the particle was placed over here. Let me place a particle here. With a particle placed over here, it will remain here if it's water. Therefore, there isn't any rotation of water with respect to S frame. On contrary, if water freezes, this is my frame. There was a cork over here again. When water freezes, this cork, as it is solid, will be over here. It is frozen. And with respect to S frame, which is center of mass frame for us, it is prime. We'll continue. S prime. With respect to this frame, what we can say is water which has frozen, ice, is rotating. Therefore, in this case, case 1, that is marked case A. In case A, we take entire of the system to be concentrated over here and calculate alpha. Alpha, let's say about P. So we calculate alpha about P, we get it as I P into alpha is equal to torque, right? Torque due to mg. Of course, it's retarding, therefore alpha will be negative. Here we write Ip into alpha, but in this case Ip will be mentioned as I naught plus I naught y, because about this axis, which we have marked as S prime frame, about x-axis you can see rotation is apparent, you can discern rotation. So what you'll be getting is first about center of mass frame, and then what I have used over here, IP is what for us is, let me write that down here, ml squared, let us say, into alpha, where I mean the total mass is equal to torque, right? Torque same over here, I naught, and then IP. IP is what I'll be getting over here into alpha is equal to torque. Now with the sign being taken into account. So we are to keep torque intact and see for ourselves that alpha in this case is torque divided by ml square, and retardation taken into account. Alpha in this case is torque divided by, yet again retardation taken into account, I naught plus IP. It goes without saying that alpha in the first case is different from alpha in the second case, and alpha in the first case, or case A as we have marked, case A, alpha in this case will be greater, correct? Will be higher on measures. Alpha in this case will be higher than the alpha for case other than A, right? This is much lower. So the measure to the scale, if we may say that retardation in case of A, as alpha is higher, will be higher than retardation in case of B. More retardation means what is obvious. We can then say that this angle beta, make it alpha prime. This angle beta will be greater than alpha prime, owing to retardation being less. Got it? So this is question number 40, I presume, of your module, as I did indicate earlier. This is question number 40 of your module. And here we get to know that this case, would be the one which would hold the future version of more deflection. Thank you. Thank you for indulging me, class, with this question.